All right, we have another area and volume FRQ. We have f of x, which is 1 plus x plus e to the x squared minus 2x, is going to be this graph right here. And then we have g of x, which is a quartic polynomial, is this graph right here. So that's g, whereas the one in purple is f. So we have regions R and S as labeled, and we want to find the sum of the area of the regions. So basically we need to find the area of R first, which is going to be the top curve minus the bottom curve. So we have g of x minus f of x. And then we need to integrate from between these limits of integration. We know that this point is 0, 2 because they told us. So I need to find this upper limit of integration. Separately, the region of S is going to be from that same limit of integration through x equals 2. This one is going to be f of x minus g of x. So let's go ahead to our calculator and plug in f and g into the graphing screen. So you go to y equals, and under y1 I'm going to plug in the f function. So 1 plus x plus e raised to the x squared minus 2x is all up in the exponent there. And then my y4 is going to be the quartic function, so x to the 4th minus 6.5 x squared plus 6x plus 2. And then I'm going to have to first get the intersection point. So let's do a zoom 6 here. See what we see. It's going to be a little bit off from what we see in the graph because the window is different. But it ought to be able to show us that intersection point fairly easily. So I see my intersection point right there. So I'm going to go to second calc. Choice 5 is intersect. And I'm going to get my cursor next to that intersection point and hit enter 3 times. And it says my intersection point is at 1.0328. So I'll come write that in. 1.0328 is my upper limit on region R and my lower limit for region F. Then I need to go into my calculator, going back to the home screen. I'm going to do alpha F2, choice 4, do R first, integrate from 0 to 1.0328, and then I need g minus f. Now, g is the quartic. Remember that I put that in y4, and I put f into y1. So I basically need here y4 minus y1. So go into vars, y-vars function y4, subtract out vars, y-vars function y1. Make sure you're integrating with respect to x. And this component is 0.997. So go back to the integral, and I'm going to go ahead and hit second entry, because really what I want to do is just swap out here. I'm going to do vars, y-vars, function y1, minus, and I'm going to subtract out the function in y4 this time. So vars, y-vars, function y4. Then I'm going to come over and I'm going to change my limits to clear out that limit to be 2 at the top. The bottom limit will be 1.0328. And I'll hit enter and I get that this is 1.066. I'm sorry, 1.006. And if I go ahead and hit enter, bring that in, and add, just to make sure I'm adding the most detailed numbers possible, I get that my total area was 2.004. So that is the sum of the areas between, well, the sum of the two areas R and S. Okay, part B says that the region S has cross sections perpendicular to the x-axis that are squares. So for B, what I need there is going to be top curve minus bottom curve, so it'll be F minus G. Since my cross sections are squares, I need to square F minus G. and I'm integrating from, this is section S here, so I integrate from 1.0328 up through 2. And sorry about my terrible handwriting. Let me see if I can fix that a little bit here. So I need 1.0328. Yeah, that's a bit better. Okay, so go back and let's go ahead and pull this integral back in, because I go from 1.0328 up to 2. I do want y1 minus y4. I just need to square it. So I'm going to go ahead and insert a parentheses here, and I'm going to insert close parentheses, and then I'm going to hit the square button and hit enter, and I get 1.283 for my part B. Okay, part C says let h be the vertical distance between the graphs of f and g in the region S. So we're over here again. Find the rate at which h changes with respect to x when x equals 1.8. So for this one, I need, again, top curve minus bottom curve, so f minus g. That is the distance h. And then since I'm, sorry for the school announcement that interrupted a little bit. I tried to hit pause, but you never know how good it was. So here I have h equals f minus g, and they want to know the rate at which h is changing. So h prime is going to be f prime minus g prime. And they want us to evaluate that at 1.8. So we really need h prime at 1.8, which is going to be equal to f prime at 1.8 minus g prime at 1.8. So let's bring our calculator in, move it over here so we can see it. We know that we are differentiating the function in y1 and then subtracting out the derivative from y4. So let's go to alpha f2, choose the numerical derivative, choice 3, differentiate with respect to x, and we're differentiating y1, so vars, y-vars, function y1 at x equals 1.8. Then the other thing we need to do is go to alpha f2, numerical derivative again, differentiate with respect to x. This time we're going to pick the function in y4 and differentiate that with respect to x at 1.8. Then I need to subtract. I need to grab the top curve, f prime at 1.8, minus the bottom curve, f prime at 1.8, and I get negative 3.811, just to show that that's what I had on my calculator. You could also use negative 3.812.